Hi students. Welcome to Smart Tricks for Today channel.
Second PUC 2026.
ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಗೆ ಇನ್ನೇನು ಕೌಂಟ್ಡೌನ್ ಶುರುವಾಗಿದೆ. ಈ ಸ್ಪರ್ಧೆಯಲ್ಲಿ ನೀವು ಗೆಲ್ಲಲೇಬೇಕು ಅಂದರೆ ಮೊದಲು 1 ಅಂಕದ ಪ್ರಶ್ನೆಗಳನ್ನು ಗಟ್ಟಿ ಮಾಡಿಕೊಳ್ಳಬೇಕು. ಅದಕ್ಕಾಗಿಯೇ ನಿಮ್ಮ ಮುಂದೆ ತಂದಿದ್ದೇವೆ ಅತ್ಯಂತ ಪ್ರಮುಖವಾದ ಮಾಡೆಲ್ ಪೇಪರ್ ಸೆಟ್ 1 ವಿತ್ ಆನ್ಸರ್ಸ್. ಇವತ್ತಿನ ನಮ್ಮ ಟಾರ್ಗೆಟ್ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಮತ್ತು ಫಿಲ್ ಇನ್ ದ ಬ್ಲಾಂಕ್ಸ್. ಇವುಗಳಲ್ಲಿ 1 ಅಂಕವೂ ಕಳೆದುಕೊಳ್ಳದಂತೆ ಇವತ್ತು ಕಲಿಯೋಣ. ನಮ್ಮ ಈ ಪ್ರಯತ್ನ ನಿಮಗೆ ಇಷ್ಟವಾಗುತ್ತಿದ್ದರೆ ಮತ್ತು ಇಂತಹ ಹೆಚ್ಚಿನ ವಿಡಿಯೋಗಳಿಗಾಗಿ ಈಗಲೇ ನಮ್ಮ ಚಾನೆಲ್ ಅನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ನಿಮ್ಮ ಸಪೋರ್ಟ್ ನಮಗೆ ಬಹಳ ಮುಖ್ಯ.
If you have any doubts, please comment or join the Telegram channel. Let's start. Part A. Pick the correct option among the given options for all questions. Each carries 1 marks. Let's start. 1. The electric flux over a closed surface enclosing a charged particle is minus q by 6 epsilon naught. The charge of the particle is. Answer is option C. Minus q by 6. Next. 2. Two capacitors of capacitance C1 and C2, C1 is not equal to C2, are connected in parallel to an external source of potential difference V. The equation which is not applicable for the given combination is, symbols have their usual meanings. Answer is option B. V is equal to V1 plus V2. Next. 3. In case of metals, with increase in temperature. Answer is option A. The conductivity decreases. This is because in metals, when temperature increases, atoms vibrate more, causing more collisions with electrons, so conductivity decreases. Next. 4. A galvanometer can be converted into a voltmeter by connecting. Answer is option D. A high resistance in series with it. Next. 5. In the following table, column 1 is the list of magnetic property and column 2 is the list of an item related to magnetic property. Identify the correct match. Answer is option C. 6. Magnetic flux is. Answer is option B. A scalar, and its SI unit is Weber. Next. 7. The resonance frequency of a series LCR circuit remains constant even if there is any variation in the value or values of. Answer is option D. Resistance R. Next. 8. Electromagnetic waves are produced by. Answer is option C. Accelerated charges. Next. 9. A real object is placed between the pole and principal focus of a concave mirror. The image formed is. Answer is option A. Virtual and magnified. Next. 10. The waves coming from 2 coherent sources overlap at a point to give maximum intensity. The phase difference between the superposing waves may be. Answer is option B. 6 pi. Next. 11. Identify the correct statement. Answer is option D. Light waves exhibit both diffraction and polarization. Next. 12. In a photoelectric experiment, the graph related to 2 quantities is a straight line with slope equal to h by e. then it is a graph of. Answer is option C. Stopping potential versus frequency of incident light. Next. 13. The total energy of an electron revolving in nth orbit of hydrogen atom is the least for. Answer is option B. N is equal to 1. Next. 14. An example for isobars is. Answer is option D. 3H1 and 3He2. Next. 15. When a p-n junction diode is reverse biased. Answer is option A. Both the barrier height and width of depletion region increase. Next. Fill in the blanks by choosing the appropriate answer given in the bracket for all the following questions. Each carries 1 marks. 16. The net magnetic moment acquired per unit volume of a sample is called dash. Answer is magnetization. Next. 17. Lenz's law gives the dash of the induced EMF. Answer is polarity. Next. 18. The phase difference between voltage and current in a pure resistive AC circuit is dash. Answer is 0 degree. Next. 19. If the angle of incidence for a ray of light in denser medium is equal to critical angle, then the angle of refraction in rarer medium is equal to dash. Answer is 90 degree. Next. 20. The minimum energy required by an electron to escape from the metal surface is called dash. Answer is work function.
ಪಾರ್ಟ್ ನಲ್ಲಿ ಬರುವ 1 ಅಂಕದ ಪ್ರಶ್ನೆಗಳನ್ನು ಯಶಸ್ವಿಯಾಗಿ ಮುಗಿಸಿದ್ದೇವೆ. ಈಗ ನಮ್ಮ ವಿಶ್ಲೇಷಣೆಯ ಮುಂದಿನ ಹಂತಕ್ಕೆ ಹೋಗೋಣ. ಪಾರ್ಟ್ ಬಿ 2 ಅಂಕದ ಪ್ರಶ್ನೆಗಳು. ಇದು ನಿಮ್ಮ ಪರೀಕ್ಷಾ ಸ್ಕೋರ್ಗೆ ಬಹಳ ಮುಖ್ಯವಾದ ವಿಭಾಗ. ಪಾರ್ಟ್ ಬಿಯಲ್ಲಿ ಪ್ರತಿ ಪ್ರಶ್ನೆಗೆ 2 ಅಂಕಗಳು ಇರುತ್ತವೆ ಮತ್ತು ನೀವು ನಿರ್ದಿಷ್ಟ ಸಂಖ್ಯೆಯ ಪ್ರಶ್ನೆಗಳಿಗೆ ಉತ್ತರಿಸಬೇಕಾಗುತ್ತದೆ. ಈ ಪ್ರಶ್ನೆಗಳು ಹೆಚ್ಚಾಗಿ ತಿಳಿದಿರುವಿಕೆ ಮತ್ತು ಅನ್ವಯಿಸುವಿಕೆ ಆಧಾರಿತವಾಗಿರುತ್ತವೆ. ಈ ಭಾಗದಲ್ಲಿ ನೀವು ಮುಖ್ಯವಾಗಿ ಡೆಫಿನಿಷನ್ಸ್, ಶಾರ್ಟ್ ಡಿಫರೆನ್ಸಸ್ ಮತ್ತು ಪ್ರಮುಖ ಅಂಶಗಳನ್ನು ವಿವರಿಸುವಂತಹ ಪ್ರಶ್ನೆಗಳನ್ನು ನಿರೀಕ್ಷಿಸಬಹುದು. ಪ್ರತಿ ಉತ್ತರವನ್ನು ಸಂಕ್ಷಿಪ್ತವಾಗಿ, ಸ್ಪಷ್ಟವಾಗಿ ಮತ್ತು ಪ್ರಮುಖ ಪಾಯಿಂಟ್ಗಳೊಂದಿಗೆ ಬರೆಯುವುದು ಹೇಗೆ ಎಂಬುದನ್ನು ಈಗ ನಾವು ನೋಡೋಣ.
Let's start. Part B. Answer any 5 of the following question. Each question carries 2 marks. Let's start. 21. Define electric field at a point. What is meant by source charge? Answer. Electric field. It is the electric force experienced per unit positive charge at a point in an electric field. Source charge. The charge which produces the electric field is called source charge. Next. 22. The electrostatic potential energy of a system of 2 like charges is positive. Explain. Answer. When 2 like charges, both positive or both negative, are brought close, work must be done against the repulsive force to bring them nearer. This work done is stored as electrostatic potential energy, which is positive because the force between like charges is repulsive. Next. 23. Name the mobile charge carriers in metals. Write the expression for mobility in terms of average collision time, relaxation time, for charge carriers. Answer. Free electrons are the mobile charge carriers in metals. Mobility, mu. The ratio of magnitude of drift velocity to the applied electric field is called mobility. That is, mu is equal to Vd by E, where mu is equal to mobility, Vd is equal to drift velocity, and E is equal to applied electric field. Next. 24. What is the nature of the force between two parallel conductors carrying currents in the A. same direction and B. opposite direction? Answer. The force between two parallel conductors depends on the direction of the currents. A. In the same direction. It is attractive force when the currents flow in the same direction. B. In the opposite direction. It is repulsive force when they flow in opposite directions. Next. 25. Calculate the magnetic energy stored in a coil of self-inductance 0.05 Henry carrying a current of 0.2 ampere. Answer. Given is self-inductance L is equal to 0.05 Henry. Current I is equal to 0.2 ampere. To calculate the magnetic energy stored in a coil, use the formula U is equal to 1 by 2 L I square. Now, substitute the values in the above formula, we get U is equal to 1 by 2 into 0.05 into 0.2 square. That is, U is equal to 0.5 into 0.05 into 0.04. On multiplying we get U is equal to 0.001 joule. Therefore, magnetic energy stored is 0.001 joule. Or we can also write as, just move this point just after 1. We get 1 into 10 to the power minus 3 joules. Next. 26. Name the electromagnetic waves used in 1. The radar systems of aircraft. 2. The laser-assisted eye surgery, LASIK. Answer. 1. The radar systems of aircraft is microwaves. 2. The laser-assisted eye surgery, LASIK, is ultraviolet light waves. Because 1. Microwave. Microwaves have short wavelengths and high frequencies, allowing them to travel long distances, penetrate atmospheric conditions like fog, clouds, and rain, reflect strongly from metal objects, provide accurate detection and ranging. So, aircraft radar systems commonly operate in the microwave range, especially in the X-band and S-band frequencies. And for 2. The laser-assisted eye surgery. Specifically, LASIK uses an excimer laser that emits UV light of wavelength 193 nanometers. UV excimer lasers can precisely reshape the cornea. They remove tissue without causing thermal damage to surrounding areas. Next. 27. Give any two limitations of Bohr's atomic model. Answer. 1. It applicable only to hydrogen and hydrogen-like, that is which have single electron, atoms. Hydrogen-like ions such as helium+, lithium +2. It fails for multi-electron atoms because it cannot explain electron-electron interactions. 2. It could not explain the fine structure of spectral lines. Splitting of spectral lines due to spin, relativistic effects, or the Zeeman effect or magnetic field effect is not explained. 3. No explanation of the uncertainty principle. Bohr assumed electrons move in fixed circular orbits, which contradicts the Heisenberg uncertainty principle. 4. It does not explain the shape of orbitals. Modern quantum mechanics shows electrons exist in probability clouds, orbitals, not fixed orbits. 5. Failure to explain chemical bonding and spectra of complex atoms. Bohr's model cannot account for the spectral intensities or chemical behavior of atoms. If they ask only limitations, just write any two from this 5. And, if they ask limitations with reason, then write these explanations also. Next. 28. List out two differences between p-type and n-type semiconductors. Answer. P-type semiconductor. It is formed by doping trivalent impurity. For example, boron, gallium, aluminium, etc. For n-type semiconductor, it is formed by doping pentavalent impurity. For example, phosphorus, arsenic, antimony, etc. In p-type semiconductor, majority carriers are holes. In n-type semiconductor, majority carriers are electrons. In p-type semiconductor, minority carriers are electrons. In n-type semiconductor, minority carriers are holes. In p-type semiconductor, acceptors create acceptor energy levels just above the valence band. In n-type semiconductor, donors create donor energy levels just below the conduction band. In p-type semiconductor, carries positive charge due to hole movement. In n-type semiconductor, carries negative charge due to electron movement. In p-type semiconductor, Fermi level lies closer to the valence band. In n-type semiconductor, Fermi level lies closer to the conduction band. You can write any two from this above differences. This complete part B. Let's start. Part C. Answer any 5 of the following questions. Each question carries 3 marks. Question number 29. Next. Expression for the torque, couple, acting on an electric dipole placed in a uniform electric field. From the figure. Consider an electric dipole placed in a uniform electric field, E. Let plus Q and minus Q are two charges of dipole. P is dipole moment acting from minus Q to plus Q. 2A is distance between two charges. Theta is angle between the directions of E and P. Therefore, force acting on plus Q is F is equal to QE. Along E, force acting on minus Q is F is equal to minus QE, opposite to E. These two forces, that is F plus Q and F minus Q, are two equal and opposite force acting on the dipole. As a result, torque is acting on the dipole. Therefore, torque is equal to magnitude of either force into perpendicular distance. That is, τ is equal to EQ into BO. Mark it as equation number 1. To find BO from triangle BOA, sin theta is equal to BO by AB. Therefore, BO is equal to AB sin theta. But AB is equal to 2A. Therefore, BO is equal to 2A sin theta. Mark it as equation number 2. Now, substitute equation 2 in equation 1. We get τ is equal to EQ into BO. That is, τ is equal to EQ into 2A sin theta. But Q into 2A is equal to P. Therefore, Tau is equal to EP sin theta. This is the expression for torque acting on the dipole. Vector form of torque acting on electric dipole moment. Vector tau is equal to vector P into vector E. Next. 30. What is a capacitor? Mention any two factors on which capacitance of a parallel plate capacitor depends. Answer. Capacitor is a system of two conductors separated by an insulator to store electric charge and electric energy. Capacitance of parallel plate capacitor depends on 1. Directly proportional to the area of each plate. 2. Inversely proportional to the distance between the plates. 3. Directly proportional to the dielectric constant of the medium between the plates. Next. 31. In a chamber, a uniform magnetic field of 6.5 into 10 to the power minus 4 Tesla is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power 6 meter per second normal to the field. Determine the radius of the circular orbit. Given, E is equal to 1.6 into 10 to the power minus 19 coulomb, and ME is equal to 9.1 into 10 to the power minus 31 kilograms. Answer. Given. Magnetic field strength, B is equal to 6.5 into 10 to the power minus 4 Tesla. Speed of the electron is equal to 4.8 into 10 to the power 6 meter per second. Charge on the electron, E is equal to 1.6 into 10 to the power minus 19 coulomb. Mass of the electron, ME is equal to 9.1 into 10 to the power minus 31 kilograms. Therefore, magnetic force exerted on the electron in the magnetic field is given as F is equal to EVB sin theta. Angle between the short electron and magnetic field, theta is equal to 90 degree. So, this force provides centripetal force to the moving electron. Hence, the electron starts moving in a circular path of radius r. Hence, centripetal force exerted on the electron. Fe is equal to mv square by r. In equilibrium, the centripetal force exerted on the electron is equal to the magnetic force, that is, Fe is equal to F. Substitute values in above equation, we get mv square by r is equal to EVB sin theta. Now, equate to r. Here both we get cancelled, so we get r is equal to mv by be sin theta. Therefore, r is equal to 9.1 into 10 to the power minus 31 kilograms into 4.8 into 10 to the power 6 meter per second by 1.6 into 10 to the power minus 19 coulomb into 6.5 into 10 to the power minus 4 Tesla into sin 90 degree. Here, sin 90 degree is equal to 1. Therefore, on simplifying, r is equal to 43.68 into 10 to the power minus 25 by 10.4 into 10 to the power minus 23. That is equal to 4.2 into 10 to the power minus 25 plus 23. Therefore, r is equal to 4.2 into 10 to the power minus 2 meter. Also we can write as r is equal to 4.2 centimeter. Hence, the radius of the circular orbit of the electron is 4.2 centimeters. Next. 32. Mention any three properties of magnetic field lines. Answer. 1. Magnetic field lines form continuous closed loops. Because they emerge from the north pole of a magnet and enter the south pole, returning through the magnet's interior. 2. No two magnetic field lines intersect. Because, if they did, the field would have two directions at the same point, which is impossible. 3. The density of field lines represents the strength of the magnetic field. Because, closer line have strong field, and wider spacing have weak field. 4. Field lines are denser near the poles. Because, the magnetic field is strongest at the poles of a magnet. 5. Outside the magnet, field lines travel from north to south. Inside, they go from south to north. 6. Magnetic field lines exert lateral pressure on each other. This is why they tend to spread out sideways and repel each other. 7. They show the direction of the magnetic force on a north test pole. Next. 33. Describe the coil and bar magnet experiment to demonstrate the phenomenon of electromagnetic induction. Answer. The arrangement consists of a coil, C1, with a galvanometer, G, and a bar magnet as shown in figure. When a magnet is moved towards a coil, the galvanometer attached to the coil shows deflection. On one side, this indicates that electric current is induced in the coil. When a magnet is moved away from the coil, galvanometer shows deflection but in opposite side, which indicates reversal of the current's direction. When there is no relative motion between the magnet and coil, the galvanometer shows no deflection. It shows that there is a production of current, EMF, in the coil when there is a change in magnetic flux. Next. 34. Draw the ray diagram for the formation of image by a compound microscope. Write the expression for linear magnification produced by the objective of compound microscope in terms of its tube length. Answer. Diagram of compound microscope, as shown in figure. Where AB is object. A dash B dash is intermediate image. A double dash B double dash is final image. U is object distance. D is image distance. F naught is focal length of object. FE is focal length of eyepiece. L is length of tube. Here, compound microscope has two lenses. The lens nearest to the object is called objective. The lens nearest to the eye is called eyepiece. Objective is a convex lens of short focal length and small aperture. Eyepiece is also a convex lens but of large aperture and large focal length. When the object AB is placed at a distance greater than the focal length of the objective, a real inverted and magnified image A dash B dash is formed. The position of the eyepiece is adjusted such that A dash B dash lies within its principal focus. Hence A dash B dash serves as object to form a final image A double dash B double dash, which is virtual, erect enlarged image. Therefore, magnifying power of a compound microscope is M is equal to M naught into ME. That is equal to L by F naught into bracket D by FE. Where F naught is focal length of object. FE is focal length of eyepiece. L is length of tube. D is least distance of distinct vision. Next. 35. What are matter waves? Explain the de Broglie hypothesis of matter waves. Answer. Matter waves are waves associated with moving particles of matter, such as electrons, protons, atoms, etc. They are also called de Broglie waves. Explanation. De Broglie hypothesis of matter waves. A French physicist Louis de Broglie suggested that the particles like electron, protons, neutrons etc. have also dual nature, i.e., the material particle can behave both wave as well as particle. According to quantum theory, the energy of a photon is given by E is equal to h nu. That is equal to hc by lambda. Mark as equation 1. Where h is a Planck's constant, nu is the frequency of a photon. According to Einstein's mass-energy equivalence, the energy of a photon is E is equal to mc square. Mark as equation 2. From 1 and 2, we have hc by lambda is equal to mc square. Here c get cancelled. Therefore, h by lambda is equal to mc. Therefore, lambda is equal to mc by h. Since mc is equal to p, where p is momentum of photon, therefore, lambda is equal to p by h. Next. 36. Differentiate between nuclear fission and nuclear fusion. Answer. Nuclear fission and nuclear fusion. 1. Nuclear fission. It is a heavy nucleus splits into two or more lighter nuclei. Nuclear fusion. It is two light nuclei combined to form a heavier nucleus. 2. Nuclear fission requires low energy, that is moderate temperature, to start. Nuclear fusion requires very high temperature to start. 3. Nuclear fission releases large amount of energy. Nuclear fusion releases much larger amount of energy than fission. 4. For nuclear fission, example, splitting of uranium-235, plutonium-239. For nuclear fusion, example, fusion of deuterium and tritium in the sun. 5. Nuclear fission produces radioactive waste. Nuclear fusion produces very little radioactive waste. 6. Nuclear fission occurs in nuclear reactors and atomic bombs. Nuclear fusion occurs in stars like the sun and hydrogen bombs.
ಈಗ ಪರೀಕ್ಷೆಯ ಅತಿ ಮುಖ್ಯ ಭಾಗವಾದ ಪಾರ್ಟ್ 5 ಅಂಕದ ಪ್ರಶ್ನೆಗಳ ಸರದಿ.
Question number 37. Derive an expression for electric potential at a point due to a point charge. Answer. From figure. Q is point charge at origin O. R is distance between O and P. X is distance between O and A. Dx is distance between A and B. E is electric field due to point charge Q. Q0 is unit positive charge is equal to +1 coulomb. According to Coulomb's law, F is equal to 1 by 4 pi epsilon naught, Q0 by x square. But Q0 is equal to 1. Therefore, F is equal to 1 by 4 pi epsilon naught, Q by x square. Mark as equation 1. Small work done in bringing a unit positive charge Q0 from A to B is dW is equal to minus F into dx. Mark as equation 2. Negative sign indicates that work is done opposite to the direction of electric field. Substitute equation 1 into we get dW is equal to minus 1 by 4 pi epsilon naught, Q by x square into dx. Mark as equation 3. The total work done in moving 1 c of charge from x is equal to infinity to x is equal to r can be calculated by using integration. Therefore, W is equal to integration infinity to r of dW. Substitute equation 3 in this equation we get W is equal to integration infinity to r of minus 1 by 4 pi epsilon naught, Q by x square into dx. Take constant term common. That is W is equal to minus q by 4 pi epsilon naught, integration, infinity to r of 1 by x square dx. On simplification, that is, integration of 1 by x square is equal to minus 1 by x. Substituting in above equation, we get W is equal to minus q by 4 pi epsilon naught into bracket minus 1 by x infinity to r. The above equation can written as W is equal to minus q by 4 pi epsilon naught into bracket 1 by r minus 1 by infinity, where 1 by infinity is equal to 0. Then W is equal to minus q by 4 pi epsilon naught into bracket 1 by r. But V is equal to W by q, where q is equal to 1. That is V is equal to W. The final equation will be V is equal to 1 by 4 pi epsilon naught q by r. This is the expression for electric potential. Next. 38. Assuming the expression for drift velocity, derive the expression for conductivity of a material sigma is equal to ne square tau by m, where symbols have their usual meaning. Answer. Consider a cylindrical metal wire of length L and uniform cross-sectional area A. The conductor is connected to a battery as shown in figure. When a potential difference is applied across the ends of the conductor, an electric field E will be set up in the conductor. Due to this electric field, the electron drifts with a velocity Vd in direction to opposite to the direction of electric field. N is number of free electrons per unit volume. The number of free electrons for a given volume of a conductor is equal to N into volume is equal to NaL. Total charge passing through the conductor, Q is equal to NaLe. The time in which the charges pass through the conductor, T is equal to L by Vd. Therefore, the current flowing through a conductor, I is equal to Q by T. On substituting Q values, we get I is equal to NaLe by T. But L by T is equal to Vd. Therefore, the above equation is written as I is equal to NEA Vd. Mark as equation 1. Take A, this side. That is, I by A is equal to NEVD. But I by A is equal to J, that is current density. Therefore, we can written as J is equal to NEVD. But drift velocity, Vd. Vd is equal to E by m into tau. Now substitute in 2. We get J is equal to Ne into E by m into tau. Therefore, we can write as J is equal to Ne square tau by m into E. Therefore, we get J is equal to sigma E, where sigma is equal to Ne square tau by m. This is an expression for electrical conductivity. Next. 39. Derive an expression for the magnetic field at a point on the axis of a circular current loop using Biot-Savart's law. Answer. Consider a circular coil of radius r carrying a current I plane of the coil perpendicular to the paper. Let P be a point at a distance x from the center of the coil along the axis. R is radius of loop. O is center of loop. Small r is distance between dl and P. dB is magnetic field at P due to current element. According to Biot-Savart law, the magnitude of magnetic field dB is equal to mu naught by 4 pi into I dl sine theta by r square. But theta is equal to 90 degree, then sine 0 degree is equal to 1. Therefore, dB is equal to mu naught by 4 pi into I dl by r square. Mark as equation 1. From figure, small r square is equal to x square plus r square. Substitute in 1, we get dB is equal to mu naught by 4 pi into I dl by x square plus r square. Mark as equation 2. The direction of dB is perpendicular to the plane containing dl and r. On resolving the dB into two components, dBx is equal to dB cos alpha, its x component along x-axis. dBy is equal to dB sin alpha, its y component along y-axis. Thus, only the dBx components survive. That is, dBx is equal to dB cos alpha. dBx is equal to mu naught by 4 pi into I dl by x square plus r square into cos alpha. From figure, cos alpha is equal to r by small r. That is equal to r by x square plus r square to the power 1 by 2. Substitute in above equation, we get dBx is equal to mu naught by 4 pi into I dl by x square plus r square into r by x square plus r square to the power 1 by 2. On simplifying, dBx is equal to mu naught by 4 pi into I dlr by x square plus r square to the power 3 by 2. Therefore, the total magnetic field at P due to entire loop is given by integration of dBx is equal to integration of mu naught by 4 pi into I dlr by x square plus r square to the power 3 by 2. Therefore, B is equal to mu naught IR by 4 pi into bracket x square plus r square to the power 3 by 2 into integration of dl. But integration of dl is equal to 2 pi r, that is circumference of loop. Therefore, B is equal to mu naught IR by 4 pi into bracket x square plus r square to the power 3 by 2 into 2 pi r. On simplifying, B is equal to mu naught IR square by 2 into x square plus r square to the power 3 by 2. This is expression for the magnetic field at a point on the axis of a circular current loop using Biot-Savart's law. Next. 40. What is a wavefront? Derive Snell's law for a plane wave undergoing refraction using Huygens principle. Answer. The locus of points which oscillate in same phase is called a wavefront. 2. Let Mn is interface. N1 is refractive index of medium, 1. N2 is refractive index of medium, 2, here, N2 greater than N1. V1 is speed of light in medium, 1. V2 is speed of light in medium, 2. AB is plane wavefront incident on Mn. I is angle of incidence. R is angle of refraction. CD is equal to refracted wavefront. The distances BC and AD are traveled by light in same time, t. In a time, t, secondary wavelet from B falls on the surface Mn traveling a distance BC. Therefore, BC is equal to V1 into t. In time, t, secondary wavelet from A will travel a distance AD. Therefore, AD is equal to V2 into t. From the figure, angle BAC is equal to I and ACD is equal to R. In triangle ABC, sin I is equal to BC by AC is equal to V1T by AC. In triangle ADC, sin R is equal to AD by AC is equal to V2T by AC. Now, divide sin I by sin R, we get sin I by sin R is equal to V1T by AC into AC by V2T. Here, AC get cancel and T also cancels. So we get sin I by sin R is equal to V1 by V2. But V1 by V2 is equal to N2 by B1. Therefore, sin I by sin R is equal to N2 by B1. On cross multiplying we get N1 sin I is equal to N2 sin R. This is expression for Snell's law for a plane wave undergoing refraction using Huygens principle. Next. 41. What is a half-wave rectifier? Draw a neat labeled circuit diagram and input-output waveforms for half-wave rectifier. Explain the working of half-wave rectifier. Answer. The rectifier which converts only half cycles of AC into DC is called half-wave rectifier. Circuit diagram and input-output waveforms for half-wave rectifier. The circuit diagram is as shown in the figure. The AC to be converted into DC is fed to the primary, P, of the transformer. A diode, D, and load resistor, RL, are connected to secondary, S, of the transformer. During positive half cycle of AC, the point A is positive potential with respect to point B, then diode is forward biased and it conducts the current. The output is obtained across the load resistance. During the negative half cycles of AC, the point A is negative potential with respect to B, then the diode is reverse biased and it does not conduct the current. The output is not obtained across the load resistance. We get the output only during one half cycles. Thus it is called half-wave rectifier. The graph of input AC and output DC is shown in the figure.
ಈಗ ನಾವು ಪರೀಕ್ಷೆಯ ಪಾರ್ಟ್ ಡಿಯಲ್ಲಿ ಬರುವ 5 ಅಂಕದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಿಡಿಸೋಣ. ಹೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳು ಈ ಲೆಕ್ಕಗಳನ್ನು ನೋಡಿ ಭಯಪಡುತ್ತಾರೆ, ಆದರೆ ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಈ ಸಮಸ್ಯೆಗಳನ್ನು ಹಂತಹಂತವಾಗಿ ಅತಿ ಸುಲಭವಾಗಿ ಹೇಗೆ ಬಿಡಿಸುವುದು ಮತ್ತು ಪೂರ್ತಿ ಅಂಕ ಪಡೆಯುವುದು ಹೇಗೆ ಎಂದು ಹೇಳಿಕೊಡುತ್ತೇನೆ.
Start. Question number 42. A positively charged spherical conductor of radius 0.1 meter produces an electric field of 1.8 into 10 to the power 3 Newton per coulomb at a point P, distance 0.2 meter from its center. Calculate the magnitude of the charge present on the spherical conductor. Also find the magnitude of new charge produced on the same spherical conductor if 5 into 10 to the power 10 extra electrons are removed from it. Answer. Here, given is radius of spherical conductor, R is equal to 0.1 meter. Distance of point P from center, small r is equal to 0.2 meter. Electric field at P, E is equal to 1.8 into 10 to the power 3 Newton per coulomb. Permittivity of free space, epsilon naught is equal to 8.85 into 10 to the power minus 12, coulomb square per Newton per square meter. N is equal to 5 into 10 to the power 10, electrons. For a point outside a charged spherical conductor, E is equal to 1 by 4 pi epsilon naught, Q by R square. On equating to Q we get Q is equal to E into 4 pi epsilon naught, R square. Substitute values in above equation. Therefore, Q is equal to 1.8 into 10 to the power 3 into 4 pi into 8.85 into 10 to the power minus 12, into 0.2 square. That is, Q is equal to 1.8 into 10 to the power 3 into 4 pi into 8.85 into 10 to the power minus 12 into 0.04. On simplifying we get Q is equal to 8 into 10 to the power minus 9. Now, for charge added, delta Q is equal to N into E. On substituting values we get delta Q is equal to 5 into 10 to the power 10 into 1.6 into 10 to the power minus 9. We get delta Q is equal to 8 into 10 to the power minus 9, column. Therefore initial charge on the conductor is delta Q is equal to 8 into 10 to the power minus 9, column. Now, for new charge, Q new is equal to Q plus delta Q. That is, Q new is equal to 8 into 10 to the power minus 9 plus 8 into 10 to the power minus 9. Therefore, Q new is equal to 1.6 into 10 to the power minus 8. Therefore, new charge after removing electrons is Q new is equal to 1.6 into 10 to the power minus 8. Next, 43. The terminal potential difference of a cell connected to an external resistance of 4 ohm is 2.4 volt. When the same cell is connected to an external resistance of 9 ohm, the new terminal potential difference becomes 2.7 volt. Find the EMF and internal resistance of the cell. Answer. Given R1 is equal to 4 ohm. V1 is equal to 2.4 volt. R2 is equal to 9 ohm. V2 is equal to 2.7 volt. Using Ohm's law, V is equal to IR. On equating, I1 is equal to V1 by R1. That is, I1 is equal to 2.4 by 4 is equal to 0.6 ampere. And I2 is equal to V2 by R2. That is, I2 is equal to 2.7 by 9 is equal to 0.3 ampere. On using EMF relation, E is equal to V plus IR. Now substitute I1 and I2 in above equation we get E is equal to 2.4 plus 0.6 R. Mark as equation 1. And E is equal to 2.7 plus 0.3 R. Mark as equation 2. Now, equate 1 and 2, we get 2.4 plus 0.6 R is equal to 2.7 plus 0.3 R. Take R at one side. We get 0.6 R minus 0.3 R is equal to 2.7 minus 2.4. So, 0.3 R is equal to 0.3. Therefore, R is equal to 1 ohm. Now, substitute R is equal to 1, value in 1. Therefore, E is equal to 2.4 plus 0.6 into 1. E is equal to 3 volt. Therefore, EMF of the cell is 3 volt. Internal resistance is 1 ohm. Next, 44. A resistor of 10 ohm and an inductor of self-inductance 0.05 Henry are connected in series to an AC source of 200 V, 50 Hz. Find the impedance of the circuit and current in the circuit. Answer. Given resistance R is equal to 10 ohm. Inductance L is equal to 0.05 Henry. Supply voltage, V is equal to 200 volt. Frequency, F is equal to 50 Hz. To find inductive reactance, XL is equal to 2 pi FL. Substitute the values, we get XL is equal to 2 into 3.14 into 50 into 0.05. We get XL is equal to 15.7 ohm. To find impedance of RL circuit, Z is equal to root of R square plus XL square. Therefore, Z is equal to root of 10 square plus 15.7 square. We get Z is equal to root of 100 plus 246.5. That is, Z is equal to root of 346.5. We get Z approximately 18.6 ohm. To find current in the circuit, I is equal to V by Z. Substitute values. That is, I is equal to 200 by 18.6. We get I is equal to 10.75 ampere. Therefore, impedance of the circuit is Z is equal to 18.6 ohm. And current in the circuit, I is equal to 10.75 ampere. Next, 45. Double convex lenses are to be manufactured from a glass of refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is to be 20 cm. Also find the new focal length of the lens if it is immersed in water of refractive index 1.33. Answer. Given refractive index of glass, mu G is equal to 1.55. Refractive index of water, mu W is equal to 1.33. Focal length in air, F is equal to 20 cm. For double convex lens, R1 is equal to plus R, R2 is equal to minus R. Therefore, lens maker's formula in air, 1 by F is equal to mu G minus 1 into bracket 1 by R1 minus 1 by R2. Substitute R1 and R2 in above equation, we get 1 by F is equal to mu G minus 1 into 2 by R. That is, 1 by 20 is equal to 1.55 minus 1 into 2 by R. Next, 1 by 20 is equal to 0.55 into 2 by R. That is, 1 by 20 is equal to 1.1 by R. On cross multiply, we get R is equal to 20 into 1.1. Therefore, R is equal to 22 cm. Now, using lens maker's formula in medium, 1 by Fw is equal to mu G by mu W minus 1 into bracket 1 by R1 minus 1 by R2. Substitute values in above equation, we get 1 by Fw is equal to 1.55 by 1.33 minus 1 into bracket 2 by 22. Now, 1 by Fw is equal to 1.165 minus 1 into 2 by 22. We get 1 by Fw is equal to 0.165 into 0.091. Therefore, 1 by Fw is equal to 0.015. So, Fw is equal to 1 by 0.015. Finally, we get Fw is equal to 66.7 cm. Therefore, radius of curvature of each surface is 22 cm. Focal length of lens in water is 66.7 cm. This ends Model Question Paper 1 questions with answers. So don't forget to subscribe the channel for more.